So we want to compare the difference in mathematics among the three groups. Here is our problem. If the X now is the home condition and it has three labels, 1, 2, 3, and the mean of our mathematical achievement is not linear. Maybe for the first group, it has the mean like this, and the second group, the third group like this. So actually, there are significant difference among the three groups. And if you don't use the strategy I'm going to introduce you, you just conduct a linear regression, then the regression line is like that. And it means by 1 unit increase in X, you have average increase in Y, right? And they are continuous the same. But actually, it's not this. There is a difference between group 1 and group 2, and another difference between group 1 and group 3. So we have to compare different groups. And the technique we are going to use is actually, we have to identify the reference group. For these three groups, we have to identify one reference group. For example, if we take this as a reference group, then we will say the group 1 is less than the reference group. And another difference between the second and third group. And you must use the technique to deal with the dummy variable for this categorical data. Because for categorical data, the number is only for indicate for the, this is the first number, second number, third number, not the value of 1, 2, 3. The value is not meaning, just only to indicate the order. Or if I can say that, can I replace 1 by 3 or change the order? I replace here. Say the first group is the 2 parents. Right now we say this is single parents, this is others, and this is 2 parents. Can I use another order like 2 parents, single parents, others?
Okay.
Of course I can.
Yeah.
But after that, it looks like a linear relationship. But it doesn't make sense, right? By different order, you will get different slopes. So you cannot just directly input the value of X into the model. You have to do something. So that is why we want to introduce you the indicator variable. So I just mentioned the core technique. The concept is to identify the reference group and then compare with it. Okay. If you have an X with 3 groups, 1, 2, 3, then you have to create a dummy variable. You have to create 2 dummy variables. We use another symbol, D1 and D2. If you have 3 labels, you will need 2 dummy variables. If you have 4 labels, you will need 3 dummy variables. Just like I mentioned, take one as reference, then compare the others with the reference group.
So, Professor, the reference group, does it mean it is the group with the highest achievement?
No, just assign one reference group. but I will show you according to the setting. The third one would be the reference group. But in other settings, maybe you will identify the second or the first group as reference group. But I have to introduce the one method for you, then you can identify which as your reference group. Now, I will define D1 as 1 if
but I don't know.
transfer and recode it into different variable. Recode some variable like here. We will recode the home into a different variable. And we have to do it twice because we have to create two dummy variables. Okay, so we do first dummy variable D1. Okay, transfer, recode it into different variable, and the input variable is home family condition. Okay, and you have to identify the name of the output variable. Give a name of output variable. I just say home. Home D1. Okay. Identify what name you like. And you have to press the button change before you set the old and new values. Okay. Before you press this button, you have to press change. You can see here. Okay. We have a name for the output variable. And then set the old and new values. So a new dialog. The old bit value in the left-hand side. In the left-hand side, you have the old value. Suppose it is 1. Then what's the value of the new value, new variable? Look here. If the individual is 1, the old value is 1. Then, what's the value for the new variable? 1. For other values, it would be 0. So I will have 1 here and 8. After you put the value of old value and new value, 8 then 1 will transfer into 1. And all other values will change into 0 for the indicator variable D1 and 8. Okay? Then we can create the dummy variable D1. Continuous. Okay? Home D1. And you can see 1 still 1, but 2 becomes 0 for D1, and 3 the same 0. Okay.
Okay.
So next step is to create another dummy variable, right?
Yeah.
So please let me know how to do. Transfer, right? And
record into different variables.
Into different. If you press into the same, it will overlap the old value into different variable. Okay, you can use reset. So it's all disappear. Let me know how to do next step.
Input
Choose
family
Variable
condition.
would be home. Family condition home.
Yeah.
The old variable. And you have to give a name for output variable.
Home D2.
It will be home D2. And change. Remember to change. Forward. After you set the old and new value, if you don't change and press OK, nothing will happen. So remember change. Okay. Then old and new value. Say 1 Actually,
Two.
for three ways, 2 would be 1. 8. 2 transferred into 1. Then others
0.
all 0. Okay,
Continue.
continue. Everything fine?
Everything okay.
Okay, now we created 2 dummy variables. So if we want to conduct the regression line, like we just did before, the x1 is anxiety score, but we want to add 2 variables, dummy variable, not the original one. Remember? So if you don't want to input the variable home as our independent variable, because home is categorical variable. Remember that students always forget when exam. And remember, if you encounter a variable is categorical, you have to change it as dummy variable before you conduct the regression line. So we will put home D1 and home D2 instead of original home. Okay. Any question?
The scale will be both home D1 and home D2. The scale is string scale or nominal, or
The scale.
yours is nominal, right?
Nominal.
Yes.
We have to change, right?
With
For previous version of SPSS, maybe 20, the previous 2018, 15, like that.
not change.
Yeah, the setting of the scale is have no meaning.
Yes.
Just for yourself. But
Okay.
the system, the SPSS will not help you to identify whether you use the method correct for nominal data or continuous data.
We have just
But if you want to know the scale of the dummy variable, of course it's independent variable, not continuous variable. For some new version of SPSS, it would block your analysis if you use wrong method. If you identify this one as nominal, then you want to calculate the mean of the variable, for example, 6, 1, 0 only. So you identify the 6 as nominal variable, right? And you want to compute the average. It don't allow you to do that because it's wrong for calculating the mean for nominal data. Yeah. But for previous version, they don't care that. Okay. Press OK. Then you will have a regression line like this. So once again, the p-value is larger than 0.05. And we just use this as an example to code in dummy variable and to illustrate the result. Okay. So can you give a quick explanation for the value 2.8? This is other, and this is two parents. This is one parents. So, how to expand the value to 2.8? reference group, right? And for D2, the slope is 2.8. It means compared with those students with two parents, those students other includes adapting grandparenting students in other condition, home condition, students in other home condition have higher score, 2.8 higher compared with the reference group in mathematical teaching. But not significant once again.
Professor, if have at least one of the subgroup significant, that means have a significant association with
Yeah, you can say that.
why?
Mm-hmm.
If I have at least one.
Right.
Yeah.
Right. That means they are not all the same. The mean value for the various groups are not all the same.
Yeah.
So of course there exists some association between the two variables. You can say that.
Yeah.
At least the one mean, at least coefficient significant.
Mm-hmm.
It means compared with the reference group, this group has higher or lower mean.